Okay, in 2.3, we're going to estimate the value of some derivatives at certain points. And one of the methods is going to be using a calculator, a graphing calculator. So I'll make a second video showing what to press on the calculator. When I show the buttons, it's going to be for the TI-84. The 83, to look up the directions, but it'll be very similar. Okay, I'll tell you before I start. To find the derivative function on my calculator, I'm going to press the button that says math. And then I'm going to go down to the 8th thing on the menu, and it's going to say nderiv. Okay, so for this first one here, it says if f of x equals the sine of root x, find f prime of 2 or the derivative of f at 2. So in my calculator, I'm going to hit math. I'm going to hit nderiv. And it's going to show me some notation. And it's going to look kind of like this. I'm going to say, okay, I'm trying to find the derivative. Since I'm using the variable x, I'm going to say in terms of x, it'll always be x. Okay, and then in my calculator, I'm going to type sine of root x. And then I want to say, I want to evaluate it at x equals 2. So there's going to be a little line here, and I'm just going to say x equals 2. And this is going to say, find the derivative in terms of x of sine root x at x equals 2. Okay, I'm going to put that in my calculator. It's going to tell me a little decimal. And I'm going to go ahead and keep 4 decimal places on this. So it's about 0.0551. And I'll show you the keystrokes on it later. Okay, one thing for sure, if you have not switched to radians, switch to radians because we're only going to use radians in this class. Okay, so for B, I'm going to go ahead and try it on my calculator as well. I'm trying to find f prime of -3. Okay, and it's asking me for an estimation using my calculator, so I'm going to put it on my calculator. Which means I could just write the answer, but I'm going to show you what I'm typing in my calculator. Okay, in my calculator, I'm finding the derivative in terms of x of the natural log of 1 over 5 minus x. Okay, and I want them to evaluate that derivative at x equals -3. Okay, I just typed in the calculator and I got around 0.1250, and I'm going to go ahead and keep 4 decimal places, and this is my approximation according to my calculator. Okay, let's go ahead and look at the next example. Okay, it says write the equation of the line tangent to y equals the square root of x over x cubed plus 1 at x equals 1. Okay, let's see. To write the equation of the line, I need an ordered pair, and I know that x is going to equal to 1. So let me figure out the y value at x equals 1. Let's call this y of 1, even though that's a little bit weird. Okay, if I plug in 1, I'm going to get the square root of 1 over 1 cubed plus 1, which is 1 plus 1. So that's going to be the square root of 1/2, which is 1 over root 2. And I'm going to leave it 1 over root 2, although this is going to be an approximation, so I could go ahead and decimal it if I want to as well. Okay, now to write the equation, I have the point. The point is 1 comma 1 over root 2. I need this slope. To find the slope, I'm going to find the derivative. So the derivative of that function at 1, when I'm putting it in my calculator, I'm going, okay, it's the derivative in terms of x of that function. Okay, and because I'm using calculator language, I'm going to say that I'm going to evaluate this at x equals 1. Okay, and then my calculator is going to give me negative 0.1768. Okay, so that's my slope. So what am I trying to find? The equation of the tangent line. So the tangent line, and I'm going to use point slope form because it is more convenient for me, at x equals 1 is going to be y minus 1 over root 2 equals negative 0.168 times x minus 1. Okay, and I might have wanted to convert this to a decimal just because this is also a decimal, so that they're both approximations, but I'm fine with it either way for now. Okay, let's go ahead and look at another method for estimating derivative. And remember, I'll make a second video showing you how to enter your calculator keystrokes. Okay, I'm going to go ahead and estimate a derivative using a table. Okay. This is going to be super approximate, but there's a couple things to keep in mind. The first thing, the function must be continuous for this to work. And they'll often tell you it is, or if they ask you to calculate it, it normally is. because otherwise the slope as we're going along, it might jump, it might do something around it. If the function is continuous, to find the slope at a certain point, you want to find the slope using points right around the x value you're trying to find the derivative of. So find the slope using points around indicated x value. Okay, so let's go ahead and look at an example. Okay, so for this one it says using the table estimate f prime of 3, and then this is a table showing some values of f of x, and we're going to assume that it is continuous for the sake of our example. Okay, I want to find f prime of 3. Okay, so 3 is right around here. It's between 2 and 4. 2 and 4, x is 2 and x is 4 are pretty evenly spaced around 3. So I'm going to find the slope of those 2 points and use that as a very rough approximation of the derivative of f at 3. So that would be f of 4 minus f of 2 over 4 minus 2, which is f of 4 is 10. F of 2 is 3 over 2, so that's 7 over 2. And in terms of units, this would be miles over hour, so miles per hour. Okay, and this is a super rough approximation. These are relatively close to 3. If I had used 0 and 7, because 3 is kind of in between those, I would have had 1 plus 2 is 3. 3 over 7 is very different answer than this. So this is going to give us a rough approximation, but it's better than nothing. Okay, so let's go ahead and look at B, and we're going to do the same thing. They want me to estimate W prime of 100, and this is a table giving me X and WX. I want W prime of 100, 10, 50, 80. So 100 is going to be between 80 and 120. It happens to be evenly spaced. That's not always the case. So I'm going to go ahead and use these because they're as close as I can get to 100, and they're on either side of 100. So the derivative of W at 100 would be W of 120 minus W of 180 because that happened, or W of 80 because that's just the information I have. Okay, W of 120 is 500. 500 minus 700 over 40. Which is about negative 50. And then what are we doing? We're doing the W of X over the X. So this is gallons per second. So gallons per second, and then I divided it by X, so it's per second again.